Okay, so good morning, everybody.
Good
Let's
morning.
Good morning.
let's share my screen. Everybody, could you see my screen?
Yes, sir.
Yes. The homework set 2. Yeah. Just at the beginning, I like to discuss a little bit. Um, I hope everybody have noticed. Do you have any questions or confusion to any problem, or you're not understanding how to do that? Anything? Does anybody have any question? Uh, The first one, there are two functions, v1, this one, and then v2. Then find their sum, v1 plus v2, just to add up those two. The question number 2, find out the input impedance of the following circuit in figure 1. And then assume that the circuit operates at omega equal to 50 radian per second. So this means in this circuit, you just need to make the total impedance, equivalent impedance, Gn, when looking from this side. So therefore, I mean, these values are given in resistance, inductance, capacitor in this format. So with the help of this omega value, first you have to convert into all components into phasor domain, and then you start doing. But as I said, so you have to look from this side, from these two terminal, you have to view it. Okay, and then question number 3, those are basically the, the rectangular or the polar conversion. What I said, evaluate and then leave your results in polar form. I mean, you have to put the final result in the polar form. And then this is that complex conjugate sign, this is star, complex conjugate. This means that first you have to make the whole operation, and then after that, at the end, you have to make complex conjugate. That is the meaning. And in this case, first this operation plus this one, then plus this one, and finally leave the result in polar form. This on a little bit big problem, long calculation. So find the current I in the circuit of figure 2. So here you have to find out the total current. So this is your AC voltage, 50 at an angle of 0. Here on good thing is that you don't need to convert into phasor domain. Already everything is given in phasor quantity. As you can see, minus J4, minus J3, J6, here J4, and of course these all are the resistances. So everything's are already expressed in phasor domain. Now find out this current. So is everybody fine? Yeah. But you see, this is a little bit tricky problem. So first you have to find out the total impedance for the whole circuit. The voltage is given. Then you can find out the current, like I equal to V over capital G. So for the entire part, you have to make it the equivalent impedance. So therefore, like as a hint, I think you may face little problem in this portion. Everybody, can you see? The problem is that this is a common point for this one and this branch. So this B point is again the common to this, and this, and C point it attached to this line and this branch and this portion. So therefore, think about this one. You need to apply here the delta Y or Y to delta conversion. I believe in case of DC circuits, although always you have only the resistive components, but you all did from delta to Y or Y to delta conversion. So in this problem, definitely you would need the help of that conversion technique. Could you follow me what I'm saying?
Right. So we're just going to calculate
the impedance and then treat the impedance like we would treat like resistance as far as it being parallel and in series with the other impedance.
Yeah. So here you see, I mean, currently the way it is given, you cannot say that, okay, this one is parallel, but you see, in between there is a point. Here there is a point. Here there is a point. So that's why I said, like you have to make here or in this loop or in this loop, some sort of delta to y or y to delta conversion. Once you do that, then you will get the clue, make series or parallel combination. Does it make sense? So
Yes.
What is this Y conversion that you speak of?
Just the delta, the bridge, like that Wheatstone bridge circuitry, that's like a delta.
you see, think this one. So is it not a delta? Think about this one. You see, this is on point. So therefore, you see, this is on whole branch. Think about 2 ohm and minus J4. This is in series, right? But this is on component combinedly. So this is on component. So therefore, this branch and J4 ohm, this is on common point of the delta. And then this J4 ohm and this 8 ohm, this is on common point of delta. And this is another common point of delta for 8 ohm and then that branch. So therefore, this on topmost on this is actually delta. Therefore, if you convert into y, then you will look, you will be getting on component here, on component here, and on component will come here. So once you do that, then you will see, you will get fun that, okay, there is some series and parallel combination. So that's all. You know that here I will not solve the full problem for you. Just I am giving you the hints. The best way to do everybody. So this is like delta. You convert delta into y. So just like on and on and on. So there will be 3 branches. And then you see how you can relate with this on. There will be series and parallel combination. And then after manipulating this one, then 12 ohm, this is in series, then you can solve. So therefore, once again, like I will not do solve the whole thing here for you. I will be discussing once you submit everything, then I will show you the result and I will solve the problem and I will discuss with you. So just as a hint, everybody please convert this top on, this is delta, convert into y. Okay, therefore you please keep trying, then you will get the clue and you will able to solve the problem. Now this one, calculate V naught T in the circuit of figure 3. So this is the voltage in time domain. So this is the time domain circuit. So the very first task will be you convert this circuit into phasor domain. That is the very first task. And then once you do that, what's the voltage across this branch? You do that. Therefore, for this problem, you need the help of current divider rule. Current divider rule. So you see, because you have to find out the voltage across this component, if you can know how much current is flowing through this branch and then multiply with this component. With this component means with its respective phasor component, phasor domain equivalent component, not directly 5 Henry. So everybody understand? If you can just know how much current is flowing here, because you are asked to find out voltage, so that current multiplied by the respective reactance value, that will be the answer. So the question is to find out the total current here. Definitely, initially, this is the total current in the circuit. And then that current is divided into 2 parts. Something is going through this component and something is going here. So you have to find out this current. And once you do, then you are able to find the voltage. Is this fine? So I believe so, yeah. And then everybody see for this problem, calculate V naught in the circuit of figure 4 using the superposition theorem. So you see, for this problem, you have to find out the voltage across this component, and this is on source. On the right side, there is another current source. So you know the how to apply the superposition. So therefore, you just apply your knowledge that you did in DC circuit. Exactly the same process. So only thing is that at the beginning, you have to convert this circuit into phasor domain. That is the number one task. And then you keep going the way you have learned in DC circuit.
Can you
Therefore,
go
in sorry.
when you finish, can you go back to number 5, please?
Oh, okay, okay. So therefore, I think so. Therefore, if anybody forgets, for example, the superposition theorem, then I must recommend you to look back that DC circuit knowledge, how you did that, and then come back to this problem. Okay. So what is the question here? Question number 5.
Okay. Couldn't we, if I was just wondering if we could just use superposition for this if the current source or the voltage source was removed, the AC power source, if it was removed, could we use superposition using the capacitor and the inductor as the sources?
So you see, there is only one source here. So you
I know,
don't need
but in the case
you,
there was,
you, you don't need to apply the superposition. Superposition theorem is when you have more than one source.
right,
You
exactly. But if there was a switch, like from the last homework, I believe it was number 5, when a switch disconnects the source,
okay?
would we use superposition for the capacitor and the inductor using them?
So first of all, there is no switch in this problem. This is not the transient problem, okay? But
Right.
what you can do, you can make an equivalent impedance of the whole thing. I mean, this one, clearly this one is parallel and then this one in series. You can make equivalent impedance. And then this is the voltage value. So you can get the total current here. So if you divide voltage by the total equivalent impedance, you will be getting total current. And once you get the total current, then you see how you will get the current here. Is this fine? Yeah. So
Yes.
you see, first of all, there is no switch here. So you cannot disconnect this source.
Right. Yes, I understand. But I'm saying in the case that if there was a switch, could we
Okay.
use superposition to solve by using the capacitor as
Yeah,
one?
yeah. If there are switch, then you could solve that. Yes.
Okay. All right. Thank you.
Okay. Yeah. Okay. Okay. Then number 7, as you can see, this is the Norton equivalent at terminals A and B. So therefore, again, if you have forgot how to do the Norton problem, then please first look back your DC circuit knowledge. Then, as I said, like again and again, I mean, everything you have learned, every rules, regulations, just here it is AC. That's the difference. And then question number 8. So I think in the last class, is it Roberto Martinez at the last moment, at the very last moment of the class, I think you were asking something about the admittance calculation, right? Series parallel. Is it Roberto
Yes, sir.
Martinez? Yes.
Yes, sir.
Yeah. So therefore, just for you, like you see, there are two problems. Clearly, you see, at omega equal to 10 to the power 3 radian per second, find the input admittances. This means for both problems, A and B, you have to find out admittance. So therefore, look this one, the way it is the mixture, like 60 is in series with this one and then parallel and then series. Same thing here, you see. You can treat this one in series and then parallel, again parallel series. So what you will be doing, you just go with that series parallel combination. I mean, for everybody, at first you calculate what is the G equivalent impedance, and then at last apply the Y. What is the relationship between Y and G? Like Y equal to 1 over G. So therefore, for both problems, you just apply the series parallel, whatever, and then at the end you convert into Y. That's all. Is this fine?
I guess so, yeah.
Yeah. So therefore, I mean, for example, the top one, 60, look, this one, 60 and that 12.5 microfarad. So of course, for both problems, first convert into phasor domain. Because you see, at the problem at the beginning, omega equal to 10 to the power 3 radian per second. Of course, you first need to convert into phasor domain. Once you do that, then for example, first problem, this two is in series, then parallel, then series. So this means that that is your like G, capital G, impedance. And then you are asked to find out Y. Just relate Y and G, Y equal to 1 over G. That's all.
Hey, Doc.
Yes.
So when you change it to polar form, it doesn't matter if it's series or if it's parallel. It's always going to be JWL or 1 over JWC.
Yeah. Yes.
Okay.
Yeah. So therefore, at the end, I mean, for the Y-in, you could leave the result either in polar form or in rectangular form, the last result. The same thing when you are manipulating, I mean, you are calculating like this plus this, for example, and then parallel, you may need to many calculations from polar to rectangular to whatever you need, you please do that. Does anybody have any other questions or comments? I think then you please keep going. Everybody, please try your best. I mean, everybody, if you can solve this properly, and everybody, if you understand, then that's great and great. Yeah, you could solve like every problem you can solve in later. Okay, so I am stop
I
sharing.
have
Ah,
I have
sorry.
a question about doing the homework.
Okay,
So most of the stuff I like to do on MATLAB, would that be okay?
math lab. Yeah.
Yes.
But I like to see your like handwritten calculation. Or you may type like in odd file or whatever format. But
Okay.
I like to see your calculation. Yeah.
Okay. That'll
Therefore,
do.
so like for verification purpose, you may use MATLAB, for example, for your own verification. But you can attach me everything. Okay, this is the method I followed.
Okay. Thank you.
Okay, yeah, thanks. Okay. Now let me.
When will we see the results for the first homework?
Oh, so hopefully next week. Hopefully at the beginning of next week. I think you are coming on September 9th, right? Coming Wednesday, you will be coming in the class. So hopefully on that day, I will be sharing you the homework. I will discuss with you. I will solve everything and then I will discuss. Is this fine? Yeah.
Yes, sir. Yes.
Okay, great. Yeah. Okay. Now, okay. Now everybody, can you see my another topic, phasor or vector diagram?
Yes, sir.
Okay. So today we will be discussing a new topic and pretty interesting and very useful in real life application. It is called phasor and vector diagram. This means you may have a circuit, for example, series circuit or parallel circuit. So with the help of diagram, I mean phasor or vector diagram, you can represent the circuit components. So, and then I have written two things. I am coming that point later. Like I have written for series circuit, use current as a reference. And for parallel circuit, use voltage as a reference. So if you apply these two techniques, then it is easy for you. So before coming that point, let's first have a look like how to draw that phasor or the vector. So everybody see this on the, for example, you have a voltage V1 6 plus Z, and then this is in the polar format. And then you have another voltage V2 3 minus J4, and it is its equivalent polar format. Now I am adding up these two. So therefore V, this V1 plus V2, you see the simply summation 6 plus 3, 9. And then this is plus J8 minus J4 plus J4. So therefore from there, I convert it into polar and this is the result. Now, because we are discussing that phasor or vector diagram, so how can I do it here? That is the, sorry, how can I do it here? That's the question. So therefore everybody, what I did, for example, the way you make the graph in geometry, exactly the same thing. This is x-axis, this is my y-axis, and look this on, first vector, v on 10 at an angle of 53.1 degree. So therefore, because the angle is positive, so I have to go anti-clockwise. Therefore, everybody see, this is my zero position, zero coordinate. So this was the x-axis. So from here, anti-clockwise, go 53.1 degree, this one. And then whatever the magnitude is, this is like 10. So this is my V1 vector. Now you plot V2. So V2 is this one. 5 at an angle of minus 53.1. So definitely, because this is minus angle, so you have to go downward, I mean the clockwise. So that's why, and its magnitude is 5. So therefore this is my V2, 5, and with respect to this reference line or x-axis, this is the angle. So now everybody see, probably in math also you have done this thing. Now I have two vector. This is on vector V1 and this is the other vector. So how to get the resultant? How you will sum them up? So therefore you see, so parallelly I am going dot 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 dot. I mean this amount is like equivalent to this one. I am going parallelly. And then this portion is like parallel to this one. You see, because as you can see, I have drawn by hand. So it may not look like perfectly parallel, but assume that this is parallel to this line. And then, so this line should be then their resultant. You understand? Therefore, as you can see, definitely that is in this side. So that is that angle, 23.96 degree. So therefore, exactly this one. So therefore, this representation is called that phasor or vector diagram for these two voltage signals, V1 and V2. Everybody, do you understand this one?
Yes, vector addition.
Yes, yes, yes. So therefore, just look their angle and accordingly you place. So this was the first vector. This is V1. Then this was V2, this one. And then you have two vector in hand, make their addition resultant. So that's why I drew this parallel line parallel to this one, and then this line is parallel to this one. So therefore this one will be my resultant. And then look clearly, automatically it is positive anti-clockwise angle, and that makes sense. In phasor calculation, I also got the result. Or in geometry, like you can do with the help of this rectangular format also. Therefore, everybody see how to do that. This is x-axis and this is the y-axis coordinate. So you see this is 0, then 1, 2, 3, 4, 5. You can plot in that way, right? The same thing. And then the upwards 1, 2, 3, you can plot. Similarly, downside -1, -2, -3, and left side you can go. So therefore, everybody see this on V1, 6 plus J8. So 6 means, for example, 1, 2, 3, 4, 5, 6, for example here. And then there is plus J8. So upward is plus J, downside is minus J. That is the meaning of J operator, you know. J means 90 degree, right? So therefore this axis is J actually. So therefore 6, for example, this is 6, and then go J8, you see this point. Therefore, I draw this line with respect to this number, I mean this polar form, but from rectangular form also, you will get the same result, like 1, 2, 3, 4, 6, and then J8. For this one, V2, you see 3 minus J4. So therefore, for example, 1, 2, 3, and then go down at J4, minus J4. That is my V2. And then so you got that. And then you make sum, again the same thing. So still you will be getting the same result. So this is just the vector. So therefore today we will be looking how we can draw the vector diagram from a circuit. Like at this moment I drew with the help of this rectangular or the polar number of two voltage functions, but with the help of circuit or from a circuit, I can draw the phasor or vector diagram. That is the thing we will be learning today. So therefore, I am coming this slide later. That everybody see a problem? Look this on. What I am asking? For the following circuit, find out the current Is through phasor diagram. This means everybody see the circuit. This is a source, voltage source. It has a, there is no voltage magnitude is given, but omega value is given. Omega 2000 radian per second. And that current I is going. And then here it is divided into two parts. Something is going through resistance, something is going through capacitor, 5 ohm, and this is 50 microfarad. So the question is, with the help of the phasor or vector diagram, find out this current. So therefore, I mean, in normal situation, I mean that without the phasor diagram, how you do that? If you can know what is the current here and what is the current here, then you will just sum up those two, right? Because this is the total current coming. That's the question. Find out the current Is, this current. So how much is going here and then how much is going here? Just you sum up those two. That is the answer. But how we can do that with the help of the phasor diagram? So now see that I have done this on, that was the circuit. You see, I have drawn a phasor or vector diagram. With the help of the phasor or vector diagram, I can solve that. So now everybody see, this is a parallel circuit, right? There is a current source, current, and that current divided two parts. This is a parallel circuit. Now, I mean, before solving, you see there are other problems. For example, you see, for this problem, this is a series circuit. I am asking for the following circuit, find out the voltage Vs through phasor diagram. So this is another example, but it is series circuit. So then come back, this was parallel circuit. Now, at the beginning, at the first slide today, what I have written, now everybody be careful. Phasor diagram for series circuit. If you see that it's a series circuit, then use current as a reference. Because to draw the phasor or vector diagram, you must need a reference, either voltage or current. But I am saying you that if it is series circuit, then please use current as a reference. If it is parallel circuit, please use voltage as a reference. I mean, the reason is that you all know that for parallel circuit, across the components, voltage remains the same. In case of series circuit, through each element, current remains the same. That is the motivation, or that's the philosophy behind these two rules. So therefore, keeping these two rules in mind, then now go back to that problem. This is the problem. And then here I was showing you the solution. Everybody see now, because this is parallel circuit, I want to find out this current with the help of phasor diagram. So first what I have to do, because this is parallel circuit, I have to assume that voltage is the reference. So you see, therefore everybody say, I drew voltage. And you see, here the magnitude is not given. That's why I assume that, suppose I wrote here, suppose V equal to what? 1 at an angle of 0 degree volt. So this is my reference line. Now, after putting the reference line, you have to plot for each component what is their current and the voltage component. So therefore, what I did, everybody look, IR, I plot it here. Then how much current is, or what is the current contribution through this component? You see, I did it in that way. And then I made the vector. Now the question is, everybody understand, now the question is, after drawing the reference line, which way you will go, how you will plot this current and how you will plot this current. For example, everybody see, I see I have gone in that way. I mean the 90-degree upward. So why I did not go in the downward? I could go in the downward. Or you see the current on, I have placed the resistance current, resistive current, or current through that 5 ohm resistance on the same line, on the same reference. So then why I did not plot in this way or that way? So that's the question. Everybody, could you follow me what I am saying?
Is
Is it because you know that the current has to be divided between the two?
Yes, no, it is. You are right that current will be divided. But what I am asking, how you will decide that, like for example, this is my reference voltage. I assume that this is on at an angle of 0. That is fine. But after that, how you will draw the vector for the current? You will
well,
go downward, or you will go upward, or
upward because the current in this case the current leads the voltage by 90 degrees.
okay, yes, that's right. So that is the thing I want to discuss. So you have to know the voltage and current relationship across each element. Right. So therefore, everybody see, like as she answered that the capacitor current will lead 90-degree. So like how she knows that? I mean, why she is telling that? Yeah. And then everybody see, I have placed the current through the resistance on the same line as the voltage. Why I have done that? Or everybody see, for example, there was a inductor as well. Inductor. If there would be an inductor, where you would place that? Still you would place in this side, or you would take it downward, or you would place it on the same line. That's the question. So therefore, everybody say, for you, I have done something.
The inductor would be placed on the bottom, wouldn't it? Because the voltage leads.
Yes, exactly. Yes, exactly. So everybody please say, I have made some conclusion. Everybody see, when it is resistance, for example, this is a resistance and its current flowing through it is IR, voltage across it is VR. So therefore, you all know that in case of in case of the resistance, voltage and current, they don't have any phase difference. They remain in the same phase. Therefore, everybody see, I have written VR equal to IR. I have assumed that IR angle is 0. For in each case, I am assuming that the current has 0 angle initially. So, I mean, this is the phasor representation, right, for the resistance that we have learned. That VR equal to IR, and then I am assuming IR has the 0 phase difference. So this means that VR and IR in phase. In phase means there is no phase difference. That's fine. Now everybody say, in case of inductor, this is L, current flowing is IL, voltage is VL. So you remember from the phasor domain or representation, VL is J omega L IL, and I am assuming IL has 0 degree. But then look the second line, everybody, what I did, because there are J means 90 degree, plus J means plus 90 degree. So what I did, omega L IL angle 90 degree. I mean in the polar format. This was in rectangular format. So this means that everybody look, VL is omega L IL 90 degree. So what does that means? This means if you plot this on, then you have to go anti-clockwise 90 degree with respect to current. Current is my reference. In each case, I have assumed current is my reference and current has 0 degree. That is my assumption in each case. So therefore, but for voltage, I am getting 90 degree. This means with respect to current, voltage will be 90 degree anti-clockwise. So this means you can say that voltage leads current by 90 degree in case of inductor. So therefore everybody say that is the conclusion I have written. Now come back capacitor. For capacitor, this is say voltage VC, then this is IC. What I have written from the phasor, VC 1 over j omega c, IC angle 0 degree. And then I have taken j in the numerator, so it is getting minus j 1 over omega c, IC 0. Now this was in rectangular format, I mean because there is j. So because there was minus j means minus 90 degree. So now what does that mean? So VC has phase angle minus 90 degree with respect to current. So this means if you say that this is your reference current, if this is the line, then minus 90 degree will be clockwise, and that is the voltage. So in other words, you can say voltage VC lags IC by 90 degree. Or in other words, IC leads VC by 90 degree. So everybody, do you understand this thing, what I am telling?
So is this true all the time of
All
all
the
VL,
time.
IL?
Exactly, all the time, all the time. So everybody from today, you must remember, in case of resistance, VR and IR in phase, there is no phase difference. This means you have to plot on the same line. If this is, okay, let me briefly take it. Hold on. Okay. Everybody please see. So when you have a resistance, for example, this is voltage and this is the current. Then if I plot it, for example, if this is current and then on the same line, it will be voltage on the same line. Because like we got V equal to RI angle 0 degree. That is the meaning. Now when it is inductor, for example, its voltage is VL and current flowing is IL. I mean, this was the inductor L. Then how to do that? For example, this was my current IL. I am assuming that this is 0 degree. This is the reference, for example. Then what conclusion I got in case of the VL? We got this conclusion that VL is omega L IL and it has the 90 degree angle. I mean in the slide that I was discussing. So therefore how to plot that? Because it is 90 degree. So this means you have to go anti-clockwise 90 degree. So therefore this is VL. So this is anti-clockwise 90 degree. So therefore you see in this case, what is the conclusion? VL leads IL by 90 degree. Or in other words, IL lags VL by 90 degree. But in case of the capacitor, this is your VC, for example, current flowing is IC. Then what conclusion we got? Like we got that expression, VC omega C, sorry, 1 over omega C, and then we got I, and we got angle minus 90 degree. That was the conclusion we got. So how to draw that on? If this is your IC, sorry, and then you see the voltage has minus 90, so voltage will be downward. That is the VC. This means voltage lags current by 90 degree. Or in other words, current leads voltage by 90 degree. Also, you could draw in that way. For example, you might plot VC here. For example, everybody see? You might plot VC as a reference. Then how to draw the current? Then definitely current will be here. Yes, because of this nature. So in other words, in case of capacitor, current leads voltage by 90 degree or voltage lags current by 90 degree. So therefore, capacitor conclusion and then inductor conclusion just opposite. Everybody see, in this case, voltage was leading current by 90 degree in case of inductor. But in case of capacitor, is it the opposite? Voltage is lagging current by 90 degree. You see this one and this one. So therefore, everybody, could you follow me?
Yes.
Okay, great. So therefore, the question is, I mean, sometimes like students got confused, like how to do that. So how to remember that? You see, it's little confusing. In case of inductor, V leads I by 90. In case of capacitor, V lags I by 90 degree. So always and always, like students just mess up these two. They like swipe these on interchange, or they apply this rule here and they apply this rule there, capacitor. I mean, resistance is fine because there is no phase difference, but always students mess up these two. Therefore, how to remember that? You see, at the bottom, I have written on a rule for you. Eli is an iceman. If you just remember this sentence, Eli is an iceman. So what does that mean? L means inductor. And you see the in the ice, the C means the capacitor. So you all know that although here I am using the symbol VVV to represent voltage, but probably in DC circuit, you have noticed that sometimes the symbol E is used to represent the voltage. Voltage means electromotive force. Electromotive force. Can you everybody remember that symbol, electromotive force? Voltage is called like potential, or sometimes it is called electromotive force. Can you remember that on voltage? I mean, what I am saying, that voltage symbol, like typically we use most cases V, but sometimes voltage is represented by the symbol E also, and E stands for electromotive force. In essential, like voltage is called the electromotive force. So that's why I am using the symbol E. So to remember, like I want to make a word here, ice. That's why I have written. So what does that mean? Everybody see ELI. ELI means when it is inductor, who is at first? I am representing voltage at first, and then the current. So it is easy to remember that voltage will lead current. Yes, you see this one, this conclusion, VL leads IL by 90 degree. I mean, so that you will not mix up with this one. And then see the ice. Ice means in case of capacitor, who is at first? Current is ahead of the voltage. That's why in this case, VC lags IC, or IC leads current, IC leads voltage by 90 degree. So therefore, everybody, if you just remember this one, ELI is an iceman, and then you will never ever make any mistake. Like L, voltage will lead current by 90 degree. In case of C, capacitor, current will lead. I mean, that way I have placed the letter that indicates the leading position. In this case, voltage is in the leading position. Everybody, could you follow me what I am saying?
Yes.
Yes. So you know that long back, like currently you are taking this circuit course. You all are like, most of you are at the junior level, right? So like long back in 1992, I was in your position, like about 20 years back, and I was learning these stuffs. That time, like we learned this thing that it is easy to remember if you remember this one, ELI is an Iceman. So exactly the same thing 28 years later, I am applying to you. So if you please remember this thing, then you will never ever make any mistake. You will not mess up with these two. That's the thing. Okay, so therefore, keeping in mind this conclusion, now please go back. This was our problem, and I was in this slide. Now everybody see, this is a parallel circuit. So for the parallel circuit, what should be the reference? We learned that the voltage should be the reference. So now everybody come back. Voltage is my reference on at an angle of 0. And then I have to plot the currents, because question was, what was the current here? So everybody answer me, where the current will go? IR current, this is resistance. Is it going this line or upward or downward? It will be on the same line, because we'll know that in case of resistance, voltage and current, they have been the same phase. That is my conclusion. In case of resistance, VR and IR in phase. This is always true, always and always the same conclusion. So that's why I drew IR in the same direction. And then what is the relationship between this voltage and the current? We learned in case of the capacitor that VC lags IC by 90 degree. In other words, IC will lead VC by 90 degree. So that's everybody see, this was my voltage. I have to go 90 degree. That is my IC. So now I got this is IR and this is IC. Then just make their resultant just parallel to this line. So this portion is parallel to this line. This is my resultant, IS. So therefore, without knowing any magnitude, whatever the magnitude, you can draw this diagram that IS will be in this direction and it will have some angle. Now to find out what is the magnitude, then you have to use those actual given numbers, given quantities. So therefore, everybody see how I wrote those numbers. Now come back here. I assume that voltage here is on at an angle of 0. So what is my IR? You know that I means V over that 5. You see, I did. So I got 0.2 angle 0 degree. And then what is my IC? You know that IC means voltage over minus JXC. But then I took the J in the denominator, 1 over J omega C. Then J omega C is going in the numerator. So J omega C V. And then this J omega value was, I think, 2000 radian per second. 2 multiplied by 10 to the power 3. Capacitor was 50 microfarad. 50 multiplied by 10 to the power minus 6. So I got J 0.1. So accordingly, I put those magnitude here. You see, ICJ 0.1, IR is 0.2. It has angle 0 degree. So then you just sum up. This is your resultant IS. So resultant is just this number and this number. So everybody, do you understand this one?
Yes.
Yes, great. Yes, so just you look and then look those things that I mean concluded here, and that will make sense. And then that is my start point. If it is parallel circuit, use voltage as a reference. If it is series circuit, use current as a reference. That's all. So now everybody go to the second problem, then you will get fun. Everybody look this problem. For the following circuit, find out the voltage Vs through phasor diagram. Now this is a series circuit, and those voltage are given. VL is J50 ohm. VR is that, the voltage across this one is VR, voltage across this one is VC, and this is a voltage source. So the question is, find out the voltage Vs through phasor diagram. Now how to draw the phasor diagram for this one? So therefore see, so that was a series circuit, right? So for the series circuit, I have everybody look, for the series circuit, I have assumed that current is my reference. I just assume that, okay, current is 1 at an angle of 0 degree ampere. So this is the line. Now you go one by one. So what is the relationship? How you will plot this on the voltage? So in case of inductor, so we have learned that inductor voltage leads the current by 90 degree. That's why I have gone upward 90 degree. And then there was resistance. What is the relationship between current and voltage? They have the same phase. They are in phase. There is no phase difference. So VR is in the same line. So that's I'm showing that, okay, VR is in the same line. Now, how about capacitor? In case of capacitor, current leads voltage 90 degree or voltage lags current by 90 degree. That's why VC will be downward and then 90 degree. So now everybody say, we got all points. We got current, we got VR, we got VL, and downward we got VC. Now what was the question? Question is find out VS. This means what was the total voltage. So therefore, how to do that? Now everybody please take care. This was my 1 voltage phasor and this was my 1 voltage VC. Make the resultant of these two. So I am making the resultant of this one and this one. So therefore, this dot line parallel to this one, parallel to this line dot. So this is my resultant. This means this VR plus VC in phasor form. I got this one. Now come back upward. Again, this was my one vector VR and in the VL here. So again make their resultant VR and this VL. So what I am getting dot parallel to this line and then dotted line parallel to this portion. So this means this is my resultant for these two. So what I am getting VL plus VR. Now you see I have two vector. One is this line VL plus VR. Other vector is VR plus VC. Now make their resultant. So therefore ultimately this dot parallel to this one. This dotted line is parallel to this one. So ultimately this is my resultant line. So therefore resultant lies on the same line. So therefore, and that makes sense. Now if you see in the circuit, to verify that, for example, if it is not the phasor diagram, what you would do, how you would solve that problem? The total voltage Vs is this voltage plus this voltage plus this voltage, right? If you know the current, just multiply with the impedance. J50 multiplied by that one, this multiplied by one current, and then this one. And then you just sum up. So therefore, I am verifying that on everybody say, Vs is VR plus VL plus VC. I assume that that current was 1 at an angle of 0. So I am getting VR is 10 multiplied by that one. I am getting VL J50 multiplied by the current J50. And then VC is minus J50. I mean, those values were given in the problem, you see. This was J50, this is minus J50, and this was 10. So if I sum up, you see, plus J50 minus J50 cancel, I just have 10 volt. And that makes sense. This is in that line, just 10 volt. The resultant voltage does not have any phase angle. It has the 0 degree. There is nothing means it has 0 degree. So it is in this line. So this means my vector diagram is correct. My phasor diagram is correct. Because from numerically, I also got the 0 degree angle, just the magnitude 10 volt. Everybody, could you follow me?
Yes.
Yeah, I'm kind of getting the idea of it.
Yes, yes. So therefore, just one thing, you know, that why you need this thing important. Like when you, I mean, after graduation, when you will be working in some company, for example, whatever your company, let's say a circuit company, a network company. So many times, instead of dealing with this type of circuit, you will notice that this is your circuit representation. So therefore, by looking the phasor diagram, you can guess, you can understand what should be the circuit elements. Therefore, everybody say, by looking this circuit, by looking the reference, you can guess what is the circuit. Therefore, in this case, everybody say, current is my reference. So what should be the circuit? It should be a series circuit. And then by looking the voltage component, you can guess what are the elements. Therefore, everybody say, this is a series circuit, and then VR is in the same phase. This means there is a resistance component in the circuit. By looking this one and this one, clearly you can guess there is an inductor and there is a capacitor. So therefore, just by looking this diagram, what is the reference and what are the components, you can construct back the circuit. That is the importance of having this phasor diagram. And why is it important? Because this is in phasor, it has only the magnitude and the phase angle. Only the magnitude and phase angle. By looking this on, you can solve many problems just with the help of the phasor calculation or vector calculation. Accordingly, it is called the phasor or vector diagram. Like if you have this circuit in front of you, then you don't need to look this circuit. Many things you can calculate. You can calculate what is its power, what is its voltage drop, etc. That is the importance of this phasor diagram. And that's why you are learning in this class that phasor or vector diagram. So in a minute, I will be discussing the last problem, then I will conclude the class. You will easily understand. For the following circuit, find out the current Is through phasor diagram. Now, you are asked to find out this current. So now, you know, in general sense, this current is this current plus this current plus this current, right? And those values are given in terms of Siemens. This means their admittance values or susceptance values are given directly. So you don't need to do anything. Already it is in phasor domain and in terms of Siemens because this is parallel circuit. Now, how I can construct the phasor diagram? So everybody see, because this is parallel circuit, definitely look the phasor diagram. Voltage should be my reference. Voltage is my reference. So if voltage is my reference, I assume dot on at an angle of 0. Now go one by one. Where the current should go for this capacitor component? Current should go 90 degree because current leads voltage by 90 degree in case of capacitor. So I went upward. For inductor, what should I do? For inductor, current will go downward because in case of inductor, voltage leads current by 90 degree. That's why I went downward current. And then how about this current? This current should be in the same line because this is resistance. So I put current in the same line. So the question was find out the total current Is. So now I got three current. I got IR here, this current. I got this current downward here, and this current I got upward. Now I have to make their resultant. So now everybody see, this is one vector IR, this is another vector IL. Just make their resultant. I mean dot 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 dot. So this is my resultant. So this is my resultant means IR plus IL. IR plus, I have given the name IX, which is you see this current, IX, IX. I mean this is going here and here. And then now come back. So I got one vector here. And then now I have IC here. Now you have this IC and you have this new vector. What is their resultant? Dot 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 upward and then dot dot dot. This is my resultant, IS line. So what is IS? IS is this IC plus this IX value that I have written. And that makes sense. That IS was actually this IC plus this current. So with the help of vector diagram, I got, and what I found, this should be the IS and that should be IC plus IX, and it should be anti-clockwise. There should be some angle here. Just vector diagram is telling me that thing. And then just verify with the help of the calculation which was given. Now come back. We assumed voltage on at an angle of 0. Then just find out three current. What is IC, what is IL, what is IR. So you see, because this is parallel circuit, what is my equation? I equal to YV. What is Y? Admittance. Because the admittances are directly given, Siemens, 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 and then V. So IC is J 0.3 Siemens multiplied by voltage V. I mean, that is YV. So from here I got J 0.3, or in other words 0.3 angle 90 degree. What is my IR? IR is again this equation 0.2, this one multiplied by voltage value on at an angle of 0. I got 0.2 angle 0. What is my IL? Again this one minus J 0.1 multiplied by voltage. I got 0.1 angle minus 90. Now come back here. What I got here? This is my own resultant. IX was IR plus IL. This means IX was IL plus IR. Just sum of those two. I got IL this one, I mean minus 0.1, and then IR 0.2. Just I wrote in rectangular format. And then what was my IS? IS is this current plus IX current. So I just sum of those two. And then I just converted those two current into polar form. So everybody see the final on IS, which was this one. You see in the vector diagram, you can see that, okay, it should be anti-clockwise positive angle. And really I got that on 45 degree. So therefore, my phasor diagram makes sense. This is valid. I have drawn the phasor diagram correctly because of the angle and then the magnitude, or whatever the magnitude is, this angle is important. It is plus. I did not get it minus. If it would be minus here, then I have drawn incorrectly. So my phasor diagram is correct. Everybody, do you understand? Is everybody's fine?
All right.
Yes. Okay. So therefore, everybody, please so have a look at home, and I already uploaded, and I'm going to upload the video. So I think today we don't have much time. So everybody, so do you have any questions